Hello, everyone. Good morning, good afternoon from wherever you're joining us. I'm very happy to have all of you here today. My name is Dalia, and I work as a community manager here at Kong. So welcome to the June user call. It's our second one for this month. Today, we're going to talk about sidecars and Kong Mesh. We have Mike with us. I will let him introduce himself. Let's take all of the questions at the end. There is a Q&A function on the bottom. You will see it. So please put all of them there rather than the chat so we can keep track of what we're answering. This webinar is being recorded, so we will send the recording out in like 2 hours with a follow-up email to everyone who joined and registered. And you will be also able to find in our YouTube channel. I will put the link in the chat. And yeah, Mike, please take it away from here. Mike, you're muted.
Okay, yeah. Thank you, Dalia.
Second try.
Yes. My name is Mike. I'm a software engineer at Kong. I work on Kong Mesh, which is the enterprise offering based on Kuma, the open source service mesh. And today I want to talk a little bit about the service mesh, how it uses sidecars, and some improvements that have recently been introduced in Kubernetes to make using sidecars even easier. I'll get my screen. So what I'm going to do is talk a little bit about sidecars in general, how they've worked up until now, and then the improvements that have come in version 129 and 130 about sidecars in Kubernetes. And then I'll do a little demo of what using the native sidecars feature looks like. So just a little bit of background. If we remember, we're talking about pods, and pods are made up of containers. And these containers inside a pod are isolated from each other, but they do share certain things. Most importantly, a network namespace, so they can communicate over the network. They can also communicate over a file system. So if they use volumes, you can share files between different containers inside a pod. And of course, they're also sharing CPU and memory on a node. But again, otherwise they're isolated. And so if we talk about sidecars, sidecars are just a pattern for using containers inside a pod. And so the idea is like, if you want to have some functionality for, say, every application in your cluster, instead of putting that functionality into each application, which they may be all written in different languages, so you might have to basically duplicate a bunch of work. Instead, you can use the container, you can use the pod concept in Kubernetes and put that functionality into a separate container, so a separate process. And then you can use the network namespace or the files that you're sharing. You can put that functionality into the sidecar, and then you can run it next to every app in your cluster. And so every app gets access to that functionality, but you don't actually have to change the app at all. You can use the same container. So in the mesh space, we use sidecars. And like I said, the idea here is the same as any sidecar. And meshes do things like, MTLS for every service in the mesh. They handle routing, so things like blue-green deployments. And they also do things like retries and a bunch of other things. And so the basic idea of the mesh is that you can put this into a sidecar, and then it's handled at an infrastructure level instead of each app team having to implement or handle this stuff on their own. And exactly, so those are the advantages. You've got like control at a different level, so things like communication, security. But the sidecar is still running per app, right? So you still have like one thing, you have security. So each sidecar is not affecting the sidecars of any other. So if if one sidecar is using a bunch of resources, so if one sidecar is using a lot of resources, this doesn't affect the sidecar of any other app, right? Yeah, exactly. So how does Kong Mesh use sidecars exactly? Well, we use Envoy. Envoy is a proxy, basically, level 4, level 7 proxy. And we put it in a sidecar, and by the magic of Kubernetes, inject it into every pod that you run on your cluster. and that's called the data plane. So Envoy and the Kuma sidecar make up what's called the data plane. So all of your traffic and your data flows through these Envoy slash Kuma sidecar containers to your app containers. And then there's a control plane running on your cluster as well, which is really Kong mesh. And the idea of the control plane data plane separation is that the control plane, so if you set up, routing, say you're doing this via a connection to the control plane, you tell the control plane what you want, and the control plane tells the data plane what you want. But your traffic never leaves the data plane, so your traffic is always flowing through Envoy sidecar that is protected by MTLS, and you get all the other features. So that's sort of the idea of the data plane versus control plane. So let's talk about containers in Kubernetes, because we were just talking in general, right? A sidecar is just a pattern, like I said. How does this actually work in Kubernetes? And it's a bit tricky. So you may know containers exist in two forms in Kubernetes. There's init containers and there's containers. And the idea of init containers is that you run these at the beginning of your pod. So your pod starts up, the init containers run, they run in a certain order, and each one of them is expected to run to completion, right? And the next one starts only after the previous one has finished. Once all of your init containers have run, then your containers are started, and they're started all at the same time. And as long as one of them is running, then your pod keeps running. So those are the only two choices we have. How do we do sidecars up until now? So meshes use the containers list for sidecars, which makes sense because if you think about init containers, you can't possibly have, say you want to have sidecar access in an init container, mesh access in an init container. Well, you can't, because there's only one init container running at a certain time, right? So you can't have a sidecar running next to your init container. It's just not, it's not possible in Kubernetes up until now. So we put it in the list of containers. Yeah, exactly. So we put it in the list of containers. Another thing to remember here is that meshes on Kubernetes are always using transparent proxy, right? So the idea of a transparent proxy is that I basically configure my pod using IP tables or eBPF so that all traffic is routed into and out of my sidecar, right? And this means that this is done either via CNI, so that it happens completely before the pod starts, or in an init container. And basically, the consequence of this is that it's very important that you order things properly. So in this case, we run a Kuma init container before Vault, right? But if you look, the Kuma init container actually configures all traffic to go to the Kuma DP sidecar, but the Kuma DP sidecar isn't running yet, right? So basically, what we get here is for init containers, we have no way of even using a mesh. So either we start the Kuma init container before Vault, in which case all traffic is broken, or we start it after Vault, in which case Vault can't actually use the mesh. So we already have a big problem with init containers and meshes. The second thing is about containers. So like I said, containers all start in parallel, right? So what happens if I start my backend and my Kuma DP sidecar at the same time? My backend comes up before my sidecar. Well, I basically have the same problem that I have with my init containers, that I start sending requests, but the Kuma DP sidecar isn't running yet. So the traffic just fails, basically, because it's redirected to a sidecar, which is not yet running. Okay, that's true in theory for containers, that they all start at the same time. In practice, it's not exactly the case. There's a little undocumented implementation detail of Kubernetes that allows you to use a post start hook to sort of hack around this limitation. And so Kubernetes starts containers in order, and it doesn't start each container until the last post start hook has finished running. So we can actually work around this if we add a post start hook to the Kuma DP container and make sure that the Kuma DP container is first. Then we can basically wait until the post. So the post start hook will be something like, check readiness, almost like a probe, check readiness of the sidecar. And once the readiness is there, we move on to the backend and start. So that we can work around this limitation with containers at least. That's how meshes work. before this native sidecar feature at startup. How about termination? Well, there's also problems with termination. Like I said, any container running means that the pod will continue running. So what about jobs? Jobs are not like long running, server API backends or anything like that. Jobs are expected to complete at some point. And what happens is, instead of backend, this should be some kind of job. So our job's finished, and I think I mixed up my pictures here. That's okay. So let's imagine the job finishes. The only container left running in the pod is the sidecar. Well, the pod is just going to keep running, which is exactly what we don't want, right? We want our pod to finish when our job is finished. So this is another thing we have to hack around. And there's different ways to do this. You can, for example, have a controller running that monitors all of the pods that have a sidecar injected. And once the controller sees, so it monitors the status of the pods, and once it sees that the pod is running and only the sidecar is running, then it can send a command to the sidecar via like a secure tunnel to tell the sidecar to stop, and then the pod will stop. Or you can, for example, wrap your job so that when it finishes, it sends a signal to the container running in the to the proxy running in the sidecar container to stop, and then you also have the sidecar container stopping there. But it's you can see that it's a lot of hacks already that we've built up to make sidecars work. Yeah, this is basically the same thing I just said. So okay, that's sidecars up until version 129. And since 2019, these problems have been known, and there's been some version of KEP 753. A KEP is basically a proposal for change in the Kubernetes API or implementation or anything. And like I said, it's been around since 2019 in some form, that they basically want to add let's say a third type of container to the Kubernetes API to basically make the expectations that we have around how sidecars work part of the guarantees of Kubernetes itself, so that not every service mesh has to hack around these things, and not every user has to mess around with their containers to make these things work. And so it wasn't actually implemented until 129, or 129 is when it entered beta. It entered alpha in 128. And there's a lot of reasons for that. A sidecar is a very basic thing, but there are a ton of use cases that you can imagine around sidecars and around additional changes you can make to the Kubernetes API for sidecars. So there was a lot of back and forth on what exactly the guarantee should be and how it should work. Eventually, there were concerns around adding the new feature when there already wasn't enough confidence in the pod lifecycle, so the implementation of the pod lifecycle in Kubernetes itself. So that's why it was delayed for a while. So things around shutdown were already unclear. And basically, there was a lot of work to be done before we could introduce another guarantee to the Kubernetes API. But eventually, it made its way to alpha and then to beta in version 129. And the API looks like this. Basically, instead of adding a new type of a new list of containers or something like this, basically a sidecar container is an init container where we declare the restart policy to be always. So that's it. I mean, so when we say a sidecar, native sidecar container, all we're talking about is an init container with the restart policy always. So I'm going to talk a little bit about what that means and how it fixes the problems that we ran into. So what do we get? With init containers, we have ordering, right? So ordering is one of the things we wanted to have. If we have a sidecar container in init containers, we get to take advantage of the ordering already of these init containers. So the ordering is kept. So if we have init container A, sidecar, init container B, we have the guarantee that init container A runs to completion, the sidecar starts, and then init container B runs to completion. And also we have the guarantee that they continue to run after the containers have started. So it looks something like this. We have Kuma init. So this is the mesh case. So we have Kuma init, sets up the transparent proxy, the IP tables rules to redirect traffic. It finishes. Kubernetes starts the kumadp sidecar. It has a startup probe, which is kind of like the post-start hook, but it's actually a part of the API this time that it's a probe. And we have all the stuff like timeouts and retries and all the things we can configure for probes. We can configure for sidecar containers. And in this case, we have a kumadp. It's declared with restart policy always. If the startup probe succeeds, then Kubernetes moves on, it leaves the kumadp init container running, and then it goes to either the next init container or the containers. So we basically solved the problem that we had with init containers, in that we can now order an init container after the kumadp sidecar, like Vault, for example, and then we have Vault able to take advantage of the mesh functionality, which wasn't possible before. And then we also have this problem with the racing of the containers themselves also eliminated, because we know the containers start only after the init containers. We also have a pretty cool guarantee. So this is kind of the restart policy part of it. Another thing that we want with Sidecar is the guarantee that if the sidecar, if the pod is running, then the sidecar must also be running. So this means, basically we have this behavior. If the kumadp restarts for whatever reason, then Kubernetes will restart it, and the pod will keep running. So we know that if the pod is running, whatever container is running in the pod have access to the init container, to the sidecar. We also have some guarantees around shutdown. So like I said before, the init containers start before the containers. We also have a similar guarantee at shutdown. So the init containers finish only after the containers finish. And it looks concretely something like this. Say we delete the pod or whatever. The first thing that Kubernetes does is send sigterm to all of the containers and waits for them to exit, then sends sigterm to the init containers. So we also know that at shutdown, there's no way for the sidecar to finish before the main container, and we don't have to do any kind of hacks around waiting in the sidecar for all of the containers to finish. Exactly, yeah. We still have shutdown hooks, so it's like pre-stop that we had before. They're triggered at the same time, asynchronously for all containers, but the sigterm still comes in order. And we'll see how we take advantage of that later on when I go into the demo to handle graceful shutdown. And maybe of note here, during emergency shutdown, so emergency shutdown is the period where the grace period has expired. So by default, it's like 30 seconds. If Kubernetes is terminating your pod and your container takes more than 30 seconds to exit after the sigterm, then it enters emergency pod shutdown, where basically in this case, the ordering is lost. We don't have the guarantee anymore. Kubernetes sends sigterm to all of the containers, waits 2 seconds, and if they still aren't exited, it sends sigkill. So just make sure as usual, make sure that your containers finish before the grace period. Just to sum up, we've eliminated a ton of problems. We have ordering, we have the ability to have any containers in the mesh at all. We know that the sidecar is always running, and we have shutdown ordering as well. And this is great because it's done by Kubernetes. Like, this means for implementers of service mesh, things have gotten a lot simpler. And it means for users, there's a lot less hacks that they have to use to take advantage of a mesh. So just the feature is beta at the moment. Still in 1.30, it's beta. It will take a while for this to become like the way to do sidecars. So there's still going to need some time for like tooling to catch up. So there's a lot of assumptions about, resource usage of pods. Like, if I want to see how many resources my pods are using, I don't look at the init containers typically, right, during steady state, because they're finished. So things like this will take a while so that there will be, let's say hurdles using these sidecar containers for a while until the feature is graduated to GA. There's still some work to do. I think in 1.31 it's planned for this to be fixed, but there's one guarantee about restarting that's not held up. So if you imagine a long running job, it's still, if you imagine, let's say, a long running job on like a preemptible node or something like this. So your container could be killed at any time. When your job is running, it's collected a lot of state or data or anything that you don't want to lose just because your node is going down. In this case, once the shutdown has begun, so once termination has begun, it's not yet guaranteed that the restart of the sidecar happens. So this is another feature, or I mean, it's not really even a feature, it's part of the guarantees about restart policy that needs to be fixed. And the reason for this is that it's a big refactor that, I mean, if you imagine typical termination of a pod, it's not expected that during termination, you want to restart a container, right? Because the whole expectation of termination is that your container is finished. So it requires a little bit of refactoring of the Kubernetes implementation to make it possible to even restart containers during termination. I think that's going to be out in version 131. So that's sort of a basic blocker for the feature graduating. Yeah, so okay, so I'm going to move into the demo now. How do you use this feature? First thing is upgrade to Kubernetes version 129 at least. And then for Kong Mesh, you just need to enable one feature, and that's it, basically. You do need to make sure your nodes are running version 129 as well. So it's not just about the control plane. The nodes need to as well, because the nodes are the actual thing that's handling the life cycle of the pods. And you still need graceful shutdown in your app, which I'll also talk about. Yeah, so let's get into the demo. So first, I'm just gonna show how, just to recap, how a sidecar looks before version 129 without this feature. So I have Kong Mesh running here, and just installed the demo app. So let's look at demo here. What do we have? We have a container. On the one hand, we have, so this is our Kuma demo container, right? It's the second container in the list of containers. The first container, like I said, is going to be the Kuma DP container. And what we also have, like I mentioned before, the hooks. No, the hook is not running. I think I didn't enable that feature. That's okay. That's basically how it looked beforehand. Now I'm going to install the control plane with the sidecar feature. And then we'll look at what happens when we do that. And then we'll look at shutdown. We can see how the guarantees work. We can see what happens with the pre-stop hook. Yeah, let's see. I need to relaunch the pods. No, actually, let's make sure that the leader has changed and our new control plane pod is running first. Okay. Yeah, so we can already see here, we have 2 init containers this time instead of 2 containers. All right, let's look at this container. Yeah, pod. Demo app. Yeah, so now we have 2 init containers instead of 2 containers. We have, which I didn't show before, but that was there before Kuma init. Again, Kuma init is the container responsible for setting up the transparent proxy. And you can also do this with the CNI. By default, it's the init container. Yeah, and now instead of under containers, which is down here, or up here, excuse me. Here we have our containers. We have one entry, just our Kuma demo container. But in init containers, now we have a second entry, which is the Kuma DP container. We can see that we have startup probe, which again is new for init containers with restart policy always, which we have here. And yeah, we also have we have a lifecycle the hooks I was talking about before, the pre-stop hook. And the pre-stop hook is important, if you remember here. So the way it works with the pre-stop hook is basically the pre-stop hook is we send a signal to the sidecar and not sig term. We can define what we do with the sidecar, and we decided to implement this with a signal. We send the signal user2, which is a user-defined signal, doesn't have a predefined meaning. We catch it in the Kuma DP process, and basically what we do then is tell Envoy to begin graceful shutdown. And graceful shutdown for a proxy is basically when you get a request, you send, if you're using HTTP2, you'll send go away, right? And if you're using HTTP 1.1, you send connection closed, which basically is a way of telling the client, don't keep this connection open. Next time send the request again, and it will be routed to a different pod, because we also, of course, when the Envoy graceful shutdown begins, we remove this pod from the set of endpoints from the mesh, right? So if you imagine right now, when I send a request to the demo app service, Envoy is managing, or the control plane is managing a set of valid endpoints for this destination. Right now, it's this pod. When we delete this pod, Envoy sees that, the control plane sees that it's going down, removes it from the set of valid endpoints. But we have to remember that Kubernetes is asynchronous, right? So the pod termination begins, and then of course the control plane process starts where it sees, okay, the pod is going down, okay, remove it from the set of endpoints, but this set of endpoints has to also be transmitted to the remaining services, right? So there's some lag time basically between, the shutdown beginning of the pod and then other services in the mesh knowing not to send requests to this endpoint, to this pod. And that's the importance of graceful shutdown, which is what we handle here in the pre-stop hook. And yeah, this is not even really a mesh issue, right? So if you even forget about the mesh, graceful shutdown is important, even if you're using service, because we still have the same asynchronous relationship between kubeproxy and pods, right? So even kubeproxy has some lag time before it stops routing requests from the service, from the cluster IP, to the pod that's going down. So that's kind of the importance of graceful shutdown. What that means for your app is, if we go to this here, so there has to be some time basically before, so the pre-stop hook begins, Envoy goes into graceful shutdown mode. Like I mentioned, it starts responding with connection close. It starts responding with HTTP2 go away. At the same time, or directly after, most likely you don't have a pre-stop hook defined for your app. You need to wait basically in your app as well, because you don't want to exit during this lag time, because you still might be getting requests from clients that haven't been updated with the fact that your pod is going down. And yeah, this is kind of the importance of graceful shutdown. So the sidecar feature doesn't eliminate that, and it never can really. That's just a fact of using Kubernetes. And there's two different ways you can do this. You can do it in your app, and I have here a demo app which I'll show. Actually does do graceful shutdown. So once it receives sig term, it waits a couple of seconds, and then finishes to make sure that there are no remaining incoming requests. You can also add a hook to your container as well, where you would just here sleep for 3 seconds. Yeah. But the best way is to handle this inside your app, because I mean, yeah, it's not even, again, it's not something that's Kubernetes specific really. It's any kind of asynchronous system. But those are basically 2 options for graceful shutdown. Right, so that's a lot of talking. Let me actually do some demoing. Let me see here. So what do we have? We have a pod running here, which is our demo app. Let's do 2 things. Let's get the logs of the sidecar, and let's get the logs of the main container. And then I'm going to stream basically the status of the pod. And this is a bunch of JSON, but we have basically 2 important things. We have the state of the app and the state of the sidecar. And at the moment, we can see that they're both, you know what, actually, first, let me make this a little bit easier to see. We'll just select the one pod instead of also looking at the other pod. That's going to come up, otherwise it will confuse the output. Yeah, so we see now that the pod is running, and the sidecar is running, it's ready. The app is running and it's ready. And I just want to show you how we can see that the guarantees of shutdown are held here. Let's see. So we're going to delete the pod. So let's, that happened very fast, but we can go back and see what happened. So we see here that, oh, I know what's happened. Hold on. I think I need to have an image which has a bit more output. Yeah. Okay. Go down, wait until the new one comes up. Just need to, I added some timestamps basically to this output so that we can see the ordering of things here. Right, it's running, okay. Logs. Okay. Okay, let's try that again. All right. We can see that again, these things happen very close to each other, but it is the case that the pre-stop hook is sent before, this pre-stop hook is sent for each container asynchronously. So we send a pre-stop, or we start the process, the go routine to start to send a pre-stop hook. We then start the next go routine to send the pre-stop hook. And then we send sigterm to the running containers, not yet the sidecars. So we can see here, the first thing that happens, remember I said the pre-stop hook is us sending a signal to the sidecar. This is the signal. We begin draining Envoy connections, which, like I said, is basically sending go away on HTTP2 and connection close on HTTP2 1.1 at 29.429. Then our app receives a sigterm at 29.444. Then we wait 3 seconds for graceful shutdown. And then we shut down at 32.449. And then Envoy gets sigterm from Kubernetes at 32.553. And when it gets that sig term, then it can shut down immediately because it knows in native sidecar mode that the main containers of the pod are no longer running. And we can also see that here. Probably sometimes a second resolution is not enough, but okay, they're running here, right? They're ready, they're started. Yeah, these come at the same time, unfortunately. Okay, we can't see it there, that's okay, but we saw it here in the output of the logs. We can also see what happens when we start up a container. That's interesting. Demo app. Let's see if we delete a pod. Demo. Okay, this pod is okay. This is the new pod. Let's scroll back. Right, so we have this pod tvj. We delete. A new pod starts. It's pending, pending, pending. Both containers are initializing. We see that remember the sidecar is here. This was started at 33. So it takes 4 seconds for it to come up, for the startup probe to succeed. And then 4 seconds later, we see that the app is started. So we see that we have these guarantees both at shutdown and startup. We can also go into the sort of the steady state, so the restart guarantees, and see what happens if we, restart the sidecar or kill the sidecar. Let's get the right exec command. Okay, we exec into the sidecar container. We can look at the logs here. The sidecar. Okay, what's happening? Let's do some PS here. We have, yeah, okay, PID1 makes sense. If we send multiple signals, here we're looking. Yeah, so we have here the restart count has increased. So we can see that the sidecar, not yet ready, but now it moves to started. Restart count is 1, so so Kubernetes API has restarted it, and now we see that it's ready again. And so that's the guarantee of that. As long as the pod is running, the sidecar is running. Yeah, feed again here. Okay, it's completed. Takes a little while for Kubernetes to restart it. No, or rather, yeah, okay. There we go. Restart count 2, started true, ready true. Yeah, basically that's the demo. Just wanted to sort of prove to you, I guess, that the Sidecar API actually does what it says it does. Yeah, so I mean, updating your Kubernetes clusters to the new version can be a challenge, but I think it's worth it, especially with jobs. It's just a lot less hacking, basically, for implementers of the mesh as well as users of the mesh to get the guarantees that we need. So yeah, that's it. Let's see. I guess Dahlia can take questions, right?
Yep. So, Mike, you can open the Q&A function and then go one by one.
Exactly. Let's see.
Do you see it?
Okay.
Yeah, the bottom.
So Ravish asks, is it available for Kuma? Yes, it is. And of course, with CNI, it's available. So with the CNI, basically, it looks exactly the same, right? So let's go into the YAML again. The difference with the CNI is that we then have no init containers because the redirecting of the traffic is handled at the node level by the CNI before the pod starts. So yeah, you definitely can use it with CNI. So with CNI, what you'd have then is you'd have the init container injected. So basically by default right now, the init container is injected first. So the sidecar is injected first into the init container list with restart policy always. So the assumption is that everything in your pod wants to use the mesh. So yeah, you basically with the CNI have the exact same guarantees. The init container, it's a bit confusing because the sidecar is an init container, but it's a special type of init container. But the sidecar container is injected first with restart policy always into the init container list. And at that point, the redirection, the transparent proxy redirection has already happened because the CNI is running. So it will just work the same. How does ordering work when we have vault in a sidecar? Let's see, what do we have here? Yeah, this annotation is basically defunct when you don't need to use this annotation when you're using the sidecar feature. The only thing is like, so yeah, I mean, the problem with the injections is that like the mutating webhooks don't run in a specific order, right? So what needs to happen with Vault init is that it needs to be first the sidecar in the init containers and then Vault init. Now, I don't exactly know off the top of my head how the Vault init container is injected, but Puma and Comesh will inject the sidecar first. So unless the Vault webhook is also injecting Vault first, it should just work. But if that doesn't work, I would be very interested to know. So if it's not going to work for you, definitely come to the Slack, the Kuma Slack, and let us know, because that's definitely a use case that we want to support. So if the Vault webhook doesn't play along, then we need to find a solution for that. Yes. Okay. Julio says thank you. Yes, you're very welcome. I think it's a pretty cool feature, so I'm happy to let people know about it. One of the features is Istio's restarting of app pods after an Istio upgrade. Yeah. Yeah. Right. No, unfortunately. So there's not really a way around it. In particular, if you're talking about upgrading the data plane, so the sidecar itself, you can't change the image of a running pod container, really. So there's no way around it except to delete the pod, and then have the new version of the control plane inject the new version of the sidecar image. And that's true, yeah. If you're using pod IP, I mean that's a common sort of complaint around sidecars that you have to do this. On the other hand, I don't know. Ideally it's okay to roll out a new version of your pod, right? So I would be interested to know what the use case for using the pod IP is. And yeah, definitely let us know in the Kuma Slack, because I don't know, maybe there's a way we can make that easier, or there's something we can improve. But yeah, if you're using the pod IP, unfortunately, there's no way around it. You're going to have a new IP. Yeah. Of course, if you're using the pod IP, I don't know, maybe are you using headless? Do you want a stable way of addressing a specific pod? You might be wanting to use headless services with like a stateful set there. Not sure. But feel free to come to the Kuma Slack. When is eBPF stable in Kuma? Is this feature built? So yes, the feature is of course in Kuma. eBPF is so yeah. The eBPF question is, where do we use eBPF in Kuma? And there's really only one place to use it, which is during the transparent proxy. So instead of using IP tables to redirect all traffic from all traffic out of the main container to the sidecar and all traffic to the pod to the sidecar, you could use eBPF to do this. And we had this feature. I don't know its stability at the moment. It may still be unstable, but it should be, I mean, it's not, we're not making any changes. We don't expect to make any changes to it. So if you want to use it, definitely let us know and we can look at the stability here, because if it's not marked as stable, then I think it's probably time to mark it as stable. I will look at that and figure out if there's something we need to do there. That's a good question. Thank you. Does Kong Mesh support plugin for tracing? Yeah, of course. That's like one of the big features of meshes. Yeah, you can do OpenTelemetry, Datadog, Zipkin, I think, are like natively supported. Of course, OpenTelemetry is probably the best way of doing it. So yeah, that means, the sidecar sends traces to the whatever collector of your choice. As usually you still need to like forward the headers from your app. So, you get a request, it has the tracing headers. When you make a new request, you still need to sort of manually in the application propagate those headers to the next request. That's something that the mesh can't do for you, because that's just a question of how do you, the semantics of your requests. That's not something the mesh can automatically do. But yeah, tracing is of course fully supported in Kong Mesh and Kuma. Performance implications. I don't think there's much in the way of performance per se, because you're still running the same containers. I think things can get I think during shutdown, so shutdown itself can be a little bit tighter, because you don't have this situation where I didn't go into that so much into the slides, but you have a situation where previously you get sigterm to the Envoy proxy, but actually the Envoy proxy shouldn't exit, right? Because it actually needs to wait for the main container to exit. And what it ends up doing is something like basically just waiting some amount of time. Or you need to synchronize basically the communication between the main container and the sidecar to make sure that the main container is really done. Okay, then the sidecar should exit immediately. This way, you don't really have to do this anymore. So I wouldn't say it's a performance improvement, but it's definitely easier to get the tightest, most compact shutdown, if that makes any sense. But in the end, yeah, you're still running the same app, you're still running the same sidecar. So performance, I think, not really so much. You tried eBPF with Cilium. Yeah, I mean, Cilium is cool technology, but eBPF is extremely complicated. And once something goes wrong, yeah, I've experienced it myself, that you end up a little bit lost on how to figure out what the actual problem is if it gets into the eBPF stuff. Yeah, that's unfortunate. Yeah, so try Kuma maybe. Try Kong Mesh. Yeah, so I guess that's the final question.
Yeah. On it, one
More
more.
questions in the chat. Oh, okay. So I think for API consumers, you probably want to look at something like Kong Gateway. Presumably Kong, I'm unfortunately not a Kong Gateway developer, so I don't know the whole feature set. But I'm pretty sure this is something that Kong Gateway would cover, because again, the Kong Gateway sits right between the consumer and the APIs, and the mesh is more about inside the APIs once you're past the gateway. So definitely look at Kong Gateway for that feature, something like that. Yeah. Okay. I guess that's it. Couple
Yeah,
more seconds.
Mike,
Any final questions? Yeah.
thank you so much for the great presentation, for answering all the questions. Great demo.
Thanks.
Let's see if we have any last questions before we wrap up.
Can you please document the init container use case? When you say document, do you mean like in the Kuma docs? Adarsh, or
Yeah.
I'm assuming he means in the, yes, okay. Yeah, that's a good point. If we don't have that in the docs, we definitely should. Thank you.
Yeah, we'll take a note and check for that. And
Yeah,
otherwise, recording will be up on the YouTube channel in like an hour. And then later today, we'll receive all of you a follow-up email with some resources from today and the recording as well. So yeah, thank you all so much for attending. Hope to see you at our next
thanks.
events in July. And Mike, thank you so much.
Thanks.
See you soon. Bye.
Yeah.